Now HDL. HDL is synthesized in liver. Liver will synthesize this molecule and the core will be kept empty. The core will be kept empty because HDL has to bring the peripheral cholesterol back to liver, right? So, liver is making a molecule which has to go and bring cholesterol back to liver. So, obviously we need empty space for bringing cholesterol, right? So, the core is empty and it has maximum proteins in it, maximum proteins in HDL, right? Also, HDL has maximum phospholipids in it. I told you all the lipoproteins have phospholipids in them. HDL has maximum phospholipids, right? So, I will be writing PL like this. P towards outer side, L towards inner side. There are lots of phospholipids, right? Then there is an enzyme LCAT. LCAT. Okay, I'll tell you the full form on next slide. And it has proteins in the periphery, proteins ApoA, C and E. Okay, this much structure is formed in liver and it will go to periphery to bring cholesterol back to liver, right? And bringing cholesterol back to liver is known as reverse cholesterol transport. Okay, HDL is doing reverse cholesterol transport. Okay, now solve these questions that exogenous triglyceride is transported to peripheral tissue by, okay, this is question number 1. Question number 2, endogenous triglyceride is transported to peripheral tissue by. Then question number 3, exogenous cholesterol is transported to peripheral tissue by whom? And endogenous cholesterol is transported by whom? So, all these questions. First is exogenous triglyceride. You know that answer is chylomicrons, right? Endogenous triglyceride is transported by VLDL. So, chylomicron and VLDL, they are transporting triglycerides. Who will transport cholesterol then? Whether it is exogenous or it is endogenous, cholesterol is transported by LDL, right? So, LDL has a very important function in body of transporting cholesterol to the peripheral tissues because many tissues require cholesterol. Cholesterol is required for vitamin D synthesis, steroid hormone synthesis, etc. Right? So, LDL has very important function. That's why earlier we were using these terms like LDL is bad and HDL is good cholesterol. But now use of this terminology is discarded because LDL has a very important function of transporting cholesterol to the peripheral tissues, right? And HDL is doing reverse of LDL. It is bringing the extra cholesterol from peripheral tissues back to liver, right? Therefore, HDL is doing reverse cholesterol transport. Now, let's do what is LCAT enzyme in HDL and why HDL has cholesterol ester as a lipid. Okay. So, HDL is formed and it will go to peripheral tissues. From peripheral tissues, it will get cholesterol, right? So it becomes HDL cholesterol, right? Now, in HDL, LCAT enzyme is there. LCAT enzyme will add one fatty acid in cholesterol. So, what we get? Cholesterol ester, right? This HDL cholesterol ester will go to liver and will give these cholesterol esters to the liver, right? Now, how this thing happens? From where is this fatty acid coming, right? Fatty acid is coming from lecithin. Lecithin is a phospholipid. And I told you HDL has maximum phospholipids. If you remember the structure of lecithin, there are two fatty acids in the structure of lecithin. So, one fatty acid can be donated here and the structure which is left is known as lysolecithin. Structure which is left is known as lysolecithin. Okay. So, now see the full form of this enzyme. full form of this enzyme LCAT is lecithin cholesterol acyl transferase. Okay. L for lecithin, C for cholesterol, A for acyl, T for transferase. Acyl means fatty acid. So fatty acid is getting transferred in this reaction. Fatty acid is taken from lecithin and given to cholesterol. Okay. So the name of the enzyme is telling you whole story. I repeat, fatty acid is getting transferred in this reaction and fatty acid is taken from lecithin and given to cholesterol. Okay. And ApoA1 is the activator of this enzyme.